everyone, welcome to DIVYA GANITHA. In this video, let us discuss the solution of Kcet 2024. Now, let's get started.
So here we have to find the equation of the line which is passing through the point. That means the numerator will be x minus 0, y minus 1 and z minus 2. In all the options we have the same numerator. Coming to the denominator part, they have given it is perpendicular to the line. Here also we have to just observe the denominators, and if the lines are perpendicular, then we know that a1 a2 plus b1 b2 plus c1 c2 equal to 0. That means the denominators we have to compare the denominators. Then if we multiply these terms, 2 into minus 3, that is minus 6, plus 3 into 4, 12, plus 3 into minus 2, minus 6, which is equal to 0. Therefore, option A is the answer. If you compare similarly for other options, will not get equal to 0. Therefore, those lines are not perpendicular. We can check here. It is 6 plus 12 minus 6. It will be 12, not equal to 0. Similarly, you can check for option C and D. Clearly, the answer is option A. The line is passing through the point minus 1, 3 and it is perpendicular to the line. There we had the three-dimensional space problem. It is 2D problem, which is a first year problem related to straight lines. To find the x-intercept, first we have to find the equation of line. For that, if we find the slope of this second line, we find the slope by the formula minus a by b. So it will be minus 1 by 6. If the lines are perpendicular, then we know that m1 into m2 is equal to minus 1. If the slope is minus 1 by 6, then the slope of the first line will be 6. Because we have m1 into m2 is equal to minus 1. We have the slope and the point by using slope point form. That is y minus y naught is equal to m into x minus x naught. If we substitute the value, then the equation of line will be y plus 3 is equal to 6 into x plus 1. If we simplify this, it will be 6x plus 6. Keep 6 as it is. If we shift this, minus 6x plus y is equal to 6 minus 3, that is 3. We want the x-intercept. For that, convert the equation into intercept form. That means x by a plus y by b is equal to 1 form. To convert it, divide the whole equation by 3. Then we get x divided by minus 1 by 2 plus y by 3 is equal to 1. This is in the intercept form. Therefore, the x-intercept is minus 1 by 2. That is option A. So, the length of latus rectum. We know that the length of latus rectum is given by 2b square by a. So, this is an ellipse. We have to convert it into standard form. To convert it into standard form, divide whole equation by 12. Then we get x square by 12 plus y square by 4 equal to 1. Therefore, a square value is 12. That means a value will be root 12 and b square value is 4. If we substitute the value, 2 into 4 divided by root 12. Root 12 can be written as 2 into root 3. So 2 will get cancelled. Therefore, length of latus rectum is 4 by root 3. That is option B. So this is a problem related to limits. They have given limit extends to 1 x power 4 minus root x divided by root x minus 1. If we substitute 1 directly, that is in the form 0 by 0. Therefore, we use L'Hopital's rule. That is, limit extends to 1 of, we differentiate both numerator as well as the denominator. Differentiation of numerator is 4x cube minus 1 by 2 root x. Similarly, if we differentiate the denominator, it will be 1 by 2 root x minus differentiation of 1 is 0. Now, substitute x equal to 1. Then we get 4 into 1, that is 4 minus 1 by 2 into root 1, that is 1 by 2 whole divided by 1 by 2. If we take the LCM and simplify, the numerator will be 7 by 2 whole divided by denominator is 1 by 2. Therefore, the answer is 7. That is option A. In this problem, they have given the function is differentiable at x equal to 0. The function is differentiable means left hand derivative must be equal to the right hand derivative. If we differentiate both the functions, it will be e power x plus differentiation of ax is a. Similarly, the differentiation of the second function will be 2b into x minus 1. This is left hand derivative as well as this is right hand derivative. We have to find at x equal to 0. If we substitute x equal to 0, e power 0 is 1 plus a, that is equal to 2b into 0 minus 1, that is minus 2b. Therefore, we have the equation, that is 1 plus a is equal to minus 2b. Now, we use inspection method. That is, substitute the value of a and b in this equation. We will check for which value the equation is satisfied. If we substitute a equal to 3, that is 1 plus 3, which is 4. If we substitute b equal to 1, it will be minus 2. So, this is not the answer. If we go for option b, 1 minus 3, that is minus 2. If we substitute b equal to 1, that is also minus 2. Therefore, the answer is option B. Similarly, you can check for option C and D. It will not be the answers. It will not satisfy the given equation. Therefore, the answer is option B. Here they have given a function. We have to check whether it is continuous or differentiable at x equal to 0. For that, to check the continuity, we have the condition limit x tends to 0 of f of x must be equal to f of 0. We know that f of 0 value is 0. So now we have to find the limit of this function. If we apply the limit directly, we cannot get the answer. Therefore, we have to simplify the given function. So how to simplify it? Limit x tends to 0. If we divide e power 1 by x to both numerator and denominator, we are dividing e power 1 by x in both numerator as well as denominator. Then we get 1 minus e power minus 1 by x divided by 1 plus e power minus 1 by x. Now if we apply the limit, this will be minus 1 by 0, which is minus infinity, and the value of e power minus infinity is 0. Therefore, the limit will be 1 minus 0 divided by 1 plus 0, which is equal to 1, and it is not equal to 0. Therefore, limit value is not equal to the function value at x equal to 0. That means the function is not continuous at x equal to 0. We have option C here, that is differentiable at x equal to 0 but not continuous at x equal to 0. We know that the function is differentiable only if it is continuous. Therefore, as the function is not continuous, it cannot be differentiable also. Therefore, answer will be option A. This is a problem related to parametric differentiation. They have given two functions y and x in terms of t. Then we have to find dy by dx. We know that dy by dx is nothing but dy by dt whole divided by dx by dt. So differentiate the function with respect to t. So the differentiation will be a into 3 sin square t into cos t. So this is dy by dt. If we differentiate this with respect to t, it will be 3a cos square t into minus sin t. Therefore, this is the value of dy by dx. If we simplify this, this is nothing but minus tan t. We have to find dy by dx at t equal to 3 pi by 4. If we substitute t equal to 3 pi by 4, it will be minus 1. Tan 3 pi by 4 value is minus 1. Therefore, answer is minus of minus 1, which is plus 1, that is option C. Again, this is a problem related to parametric differentiation. Instead of giving x and y, they have given the derivative of sin x with respect to log x. Similar to the previous problem, we have to differentiate sin x divided by the differentiation of log x. So, we know that the derivative of sin x is cos x divided by derivative of log x is 1 by x. Therefore, answer is, if we take to the numerator, it will be x into cos x. That is option A. We have to find the minimum value of 1 minus sin x. We know that the sin x lies between minus 1 and plus 1. The value will be minimum if the sin x value is maximum. That is, the maximum value of sin x is 1. Therefore, the minimum value is 1 minus 1, which is 0. To find the minimum value, we have another method which is in application of derivative, that is finding the derivative and the second derivative. That is also one of the method. Instead of doing all those things, we know the range of sin x. By using the range, we can directly find the minimum value, that is 0, option D. We have a function tan x minus x. We have to check whether it is increasing, decreasing, or neither increasing nor decreasing. For that, we know that the tan x function is always increasing and the graph is like this, right? If we consider tan x minus x, x value is always less than tan x value. Therefore, obviously tan x minus x is also a increasing function. It also always increases. That is option